language. And of course, there are many other alphabets, many. So here's sigma 2, like a second example of an alphabet, and it's a set of allowed symbols in your alphabet. Well, there are 26 Roman letters, A, B, C, X, Y, Z. Okay? And here's another alphabet. So we'll use the second one. So gamma, capital gamma, and again a set of the allowed symbols you can use in your strings. So in this case, it's 0, 1, X, Y, and Z. So in this case, a mixture of Roman letters and digits. Okay? So you define your alphabet, the allowed symbols that you can make strings from. And the string being, remember again, just a sequence of members of your alphabet. All right. We've got two chairs, one either end this time. Still evolving a methodology how to do this. Okay, so what's a string? The definition. Well, I've said it several times. So it's just usually a finite sequence. Sort of usually. I don't want to be too strict on that. But anyways, it's just a sequence of symbols from your alphabet. Right? A sequence, like there's one after the other. Usually no spacing between the symbols of your alphabet. No commas or punctuation or anything like that. Just crammed together. So give you some examples. Like if your alphabet is like the binary alphabet, so sigma 1, let's say, and here's your set of allowed symbols, like 0 and 1. So your alphabet, that's the total of allowed symbols. So your alphabet is just the set 0, 1. Okay? So a string using this alphabet, well, here's an example. It's just a binary string. Just a sequence of zeros and ones. Okay? So that is an allowed string for this alphabet, sigma 1. This alphabet here. Okay. Now, if sigma 2, let's say, as before, is just the Roman alphabet, A, B, C, X, Y, Z, then this is a string. Now, if you're not a native English speaker, this word might be a little mysterious to you. In fact, it's actually magical. I need to explain. So for the non-native English speakers, this word abracadabra, how does that arise in, let's say, native English-speaking culture? Well, imagine you're watching a magic show, and the magician is about to perform some magic trick. For example, pull a rabbit out of a hat. So just before he does that, he'll say the magic word abracadabra, abracadabra, and the rabbit comes out of the hat. Okay? So this is sort of a child's word in the context of magic tricks. Okay, so abracadabra, and it just sounds good. Abracadabra, sort of slips off the tongue. So popular with kids. All right. So anyway, this, if you look at it, it's just a sequence of letters, Roman letters, from this set, from this alphabet, in other words, sigma 2. Okay, so that is an allowable string from this alphabet, from sigma 2. Okay, now some more definitions. The length of a string. Well, you can probably just guess what it means. Like what would the length of this string be? Well, it's just the number of symbols in your sequence, right? In this case, well, do the easy case first. What's the length of this string, the binary string? Well, just 5, right? Because we have five symbols in the string. And what's the length of this one? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay? So the length of that string in this alphabet, the Roman alphabet, is 12. Okay? So length of a string is just the number of symbols in the sequence, in the string, the length of the string. Okay. Now the empty string. What happened here? I must have touched it, I think. Now the empty string has length 0. Okay? It's a string of 0 length. So there's no symbols. There are 0 symbols in the string. That's called the empty string. Right? And it has a special symbol of its own. So sort of like analogous to the empty set. Remember, it was a 0 with a stroke through it. That was the symbol given to the empty set. That's the set with 0 members, 0 elements. Well, the empty string, that's the string with 0 symbols in it. It's given its own symbol, because this concept of an empty string pops up a lot in theory of computation, and you'll get very familiar with this after, fairly soon. That symbol is the 5th letter of the alphabet, eta. Right? Sort of looks like a 3, the mirror image of a 3, sort of like that. Okay, eta. And it's sort of analogous. It's analogous to, say, 0 in arithmetic. Right? So that's the symbol given to the empty string. Okay. Now you can take a string, let's say string W, and let's say its length is n. Right? So it has n, little n symbols in the string. It's this sequence of symbols, and its length is n. So you can rewrite this string in the following way. Now the string is represented by this label W. Let's say W just stands for a string of some kind, and this string has length n, so it has n symbols in it. So you can rewrite this string in the following way: W1, W2, Wn. Okay. So that's your sequence of symbols. So that's the first symbol you use. That's the second symbol you used in the string, and that's the nth symbol. Okay. So, and each one of these symbols belongs to the alphabet that you're using. Right? Now, you can take a string of this form and you can reverse it. So, in other words, you change the order. So, this symbol here would now be the first on the left-hand side, and the second one would be the one here, and the third one, and so on. So this one would be the last. Okay? So you write the reversed form of the string in this way: W, and then as to the power R, like you've got a suffix. Well, you got an R here, raised, sort of like a power. So you have W and R, and that R there means that the string has been reversed. Okay? So if R is this, then if W is this, then WR will be this reversed. So it'll be WN, WN-1, ... W3, W2, W1. Okay, so it's written in opposite order. Okay, concept of a substring. It's sort of a slice of the string, the original string. Like, imagine this is your string W, and then I slice off a portion of it. So that would be like a substring of the whole thing. Okay, or I could make 2 cuts, and that would be a substring of the whole thing. Okay, but your substring has to be contiguous. It's not as though can't do it unless you can. Here I have a toothpick. You cannot do this. Oh, can you break them? Okay. So say I cut it twice. Now, the middle bit here the middle bit, that's a substring, okay? But if I had the two ends and put them together, that is not a substring, okay? Because they have to be contiguous. There have to be no missing. I can put this. It's a single slice, so to speak. So putting these two edges together, that would not be a substring, but the middle bit would be, or the middle and your right, yeah, as you said, together, that would be a substring, or that would be a substring, okay, and the middle one alone would be a substring. Okay, so for example, CAD, CAD, that would be a substring of the string abracadabra, because here it is here, CAD, right? Contiguous, not broken up into pieces, so to speak. Just one contiguous part of your original string. Okay, so the notion of substring. So we've done quite a few. Here, I'll just recap a little bit. So the notion of string itself. Now the topic is string and languages. We haven't talked at all about languages. That'll be for future sessions. But language is obviously strongly connected with strings. I'm still talking about concept of strings. So what's an alphabet? The convention of how to label alphabets using capital Greek letters like sigma and gamma. What's a string itself? Okay. What's the length of a string? What is the empty string? The reverse of a string and a substring. Okay, so quite a number of terms and concepts you need to memorize there. I need to get out to turn off the camera. So, good job.